All right, part 2 of 2.7. So now we're going to look at adding these two fractions together. So whenever I look at finding a common denominator, I look at the largest denominator. Well, this is the largest denominator because it's this same factor, but to the second power. So hopefully you understand that x plus 2 divides evenly into this. If I divide x plus 2 squared divided by x plus 2, I just get x plus 2. So since this is a factor of this larger denominator, that's my common denominator. So let me go ahead and erase that. So my common denominator is x plus 2 squared. So again, I look at x plus 2. What do I need to multiply x plus 2 by to get this? I need to multiply it by another x plus 2. So I need to multiply the denominator by x plus 2, which means I need to multiply the numerator by x plus 2. So if I distribute negative 5 to x plus 2, I get negative 5x minus 10. And then I look at here, x plus 2. This is already this is the denominator, x plus 2 squared, so this stays the same. And then again, when you add fractions, the denominator stays the same, and the numerator we add together. So negative 5x, negative 10 plus 4 is negative 6. So this would be my answer added together. So this is kind of important. So if you look at when you have a common factor, it's called a repeated linear factor. So you've got a linear factor. What I mean by linear is this is x to the first, and it's repeated. It's squared, or it's to the third power, or whatever. Look how your denominators have to be. You have to have the factor by itself to the first power. Then you have to have the factor by itself to the second power. If this was x plus 2 to the third power, you would need another fraction with some number at the top and x plus 2 to the third power. So that's kind of how you deconstruct a fraction so that you can get the partial fractions. Again, the first thing I look for, my numerator has a smaller degree than my denominator, so I don't need to divide them. And I need to factor the numerator. So again, what I'm looking at back up here, if I can find my... I'm going through these steps again. So I am going to factor the denominator. First thing I notice, I have a common factor of x. And then I would get x squared plus 2x plus 1. This trinomial also factors into x plus 1, x plus 1. Or another way to write that is x times x plus 1 squared. So here's that linear factor as a repeated factor. So we have to look up here how we did that with a repeated factor. So the first thing I'm going to do, I have this factor. That's going to go over x plus b over x plus 1. And then I'm going to have c over x plus 1 squared. So it's very similar to what I had here. I'm going backwards. This x plus 2 squared is equivalent to this x plus 1 squared. And you can see how I had to have a denominator of x plus 2 and a denominator of x plus 2 squared. So I'm just going backwards. So once I have this fraction, I'm not going to have room to rewrite it. So the next thing I'm going to do is multiply everything by the common denominator, which is this whole thing. So I'm going to be multiplying it by x times x plus 1 squared, x times x plus 1 squared, x times x plus 1 squared, and x times x plus 1 squared. And that's going to get rid of my fractions. That's the whole point of doing that. So we said that this is the same thing as that, so that whole thing cancels. So I'm left with 5x squared plus 20x plus 6 equals, this x will cancel with this x, so I'm left with a times x plus 1 squared plus, here this x plus 1 cancels with one of these x plus 1, so I'm just going to get rid of that exponent. So I'm left with bx times x plus 1. On this fraction, the x plus 1 squares cancel, and I'm left with c times x. So let's look at values that we can plug in to get rid of certain variables. So since my factors are x and x plus 1, what can I let x be that will eliminate some of my variables? Well, if x is 0, so let's let x be 0. I'm letting x be 0. So I'm plugging in 0 for x here. So 5 times 0 plus 20 times 0, that's 0, plus 6. So I'm left with 6 equals a times 0 plus 1 is 1 squared. So I'm left with 1 squared, which is 1, times a. So just 1a plus, if I let x be 0 here, I get b times 0, which is 0. And then 0 plus 1 is 1. 0 times 1 is 0, so that's gone. And c times 0 is just 0. So I'm left with 6 equals a. So that was pretty easy. And then if I look at the x plus 1 factor, what could I let x be so that that will cancel those factors out? Well, I'm going to let x be -1, because if I set that factor equal to 0 and solve for x, I would get x equals -1. So now I'm plugging in -1. So if you want to get your calculator out, we're plugging in -1. So over here, 5 times, and you're going to want to use parentheses, -1 squared plus 20 times -1 plus 6. So that equals -9. If I plug in -1 up here, I'm going to get -1 plus 1 is 0. 0 squared is 0. So that means this term is gone. And then if I let x be -1 in this particular term, I get -1 plus 1 is 0. Doesn't matter, 0 times anything is going to be 0, so that term's gone. And then I have c times -1, so I get -c. So then c equals 9. Now, there's not any logical thing I can plug in for x now. So now I'm just going to plug in something that's easy to plug in. So we plugged in 0, we plugged in -1. What would be something easy to plug in for x? Well, I would think +1 would be easy. So I'm just going to let x equal 1. You could let x equal 2,000, but that would be a lot of work. So I usually pick something that's easy to plug in. So get your calculator, 5 times 1 squared plus 20 times 1 plus 6 is 31. And then when I plug in 1 here, I get 1 plus 1 is 2. Squared is 4. So I have 4 times a. Well, we know A is what? A is 6. So 4 times 6 plus B, I don't know what B is. That's the whole point. I'm trying to find out what B is. Times 1 times 1 plus 1 is 2. So really that's times B times 2, or 2B, plus C, which C we found was 9. So 9 times 1 is 9. So if 31 equals 24 plus 2B plus 9. So 31 equals, oops, 24 plus 9 is 33 plus 2B. Subtract the 33 and I get negative 2 equals 2B. So B is negative 1. So now I've got what A equals, what B equals, and what C equals. So then I can find my final answer. So I'll do that. Oops, I'm getting kind of sloppy here. Sorry about that. So I've got 5x squared plus 20x plus 6, x cubed plus 2x squared plus x equals A over x. Well, we said A is 6, so 6 over x, plus B is negative 1, so actually minus 1 over x plus 1, plus C, which is 9 over x plus 1 squared. So these are the partial fractions that add to give me this original fraction. So again, that's what we're doing here. All right, so on this one, again, we look, is the numerator higher? It's not, so I don't need to divide. What I do next is I factor this denominator. Well, that is the difference of perfect cubes. And I don't know if you remember how to factor the difference of perfect cubes, but let me grab a piece of paper and show you how to do that. So if you have, here are the formulas. Not sure if you learned this in algebra. So when you factor the difference of cubes, your first factor is just A minus B. This would just be A plus B. Your second factor will be, so this is technically A cubed minus B cubed. Your second factor will be A squared. Whatever sign here is changes. Then you multiply your A times your B, and then plus B squared. That would be how you would factor this particular thing. So if your B was, I'll do an example with other numbers in a minute. So this would be A squared minus AB plus B squared. So if you had x to the third minus 8, well, this is x to the third minus 2 to the third. So then that would factor into x minus 2 times x squared plus, I multiply those together, 2x, and then I square the 2 and it would get 4. And that would factor. When you factor the difference of cube, this trinomial will never factor. So don't ever have to worry about that factoring further. All right, so that's how you factor the difference in sums of cubes. So I have to factor this. So this is going to factor into x minus 1 times x squared plus x plus 1. Again, this won't factor when you factor the difference or sum of cubes. So I have a linear factor. So I put that over a over x minus 1 plus. This factor is a quadratic factor, and it's a quadratic factor because the x is squared here. The highest power of x is second to the second power. So then you have to put a 2bx plus c. It's just how you have to do it. If you had done an a over x minus 1 and a b over x plus 2, then you would just do cx plus d. So you have to have this kind of a combination. A letter times x plus another letter. That's how you have to get this to work over this factor. So that's kind of one of those things you just kind of have to memorize, that you have to put that quadratic factor over, that will be under this little format right there. All right, so I'm going to multiply everything by the least common multiple, which is this. And here. Again, when I multiply this entire equation by this will cancel, so I'm left with just x here. And then a times this will cancel, so I have a times x squared plus x plus 1. Plus here, this will cancel, left with bx plus c, which is an entire quantity in itself, times x plus 1. All right, so things that you can plug in. What would be an obvious thing to plug in to get rid of a variable? Well, you've got this factor. So what could you plug in? You could plug in x equals -1. So I'm going to replace all my x's with -1 because that will cause this factor to be 0, which would get rid of this whole thing. And then I'd be able to find a. So I'm going to let x be -1. So -1 equals, if I plug that into my calculator, I've got, make sure you put that -1 in parentheses, squared. Oops, I should put it over here. Plus a -1 plus 1. So that's 1 times a. That's not right. So if I plug in -1, what did I do wrong here? -1 squared, that would be 1. -1. It should be 3. Oh my goodness. This is -1 and I put +1. Oh my goodness. That changes everything. So I'm going to let x be +1. That could be the problem. All right, x is +1. So when I let x be 1, so this is just 1. And then 1 squared is 1 plus 1 plus 1 would be 3. So times 3. So 1 equals 3a, a equals 1/3. So I'm still left with trying to find bx plus c. So what would be some values I could plug in that would be easier to plug in? You could let x be 0, because that's something easy to plug in. We'll see what that does. So if I let x be 0, I get 0 equals a times, if I plug in 0 here, 0 plus 1 would be 1. Oh, again, a is 1/3, so I can replace this with 1/3 plus b times 0 is 0, plus c would just be plus c. And then 0 minus 1 would be -1. So I get 0 equals 1/3 minus c. -1/3 equals -c. So c equals 1/3. So a is 1/3, c is 1/3. And now I have to find b. So I guess we could plug in -1. So we'll let x be -1. So I'm left with -1. Again, I'm coming back here to plug it in. And then a we know is 1/3. If I let x be -1 here, again, I get, let's double check. I think I get 1 when I did that. -1/2 minus 1 plus 1. Oops. Yeah, is 1. So 1/3 times 1 plus b is what we're looking for, times -1 plus c, which is 1/3. So that whole thing times -1 minus 1, which is -2. So we get -1 equals 1/3. So I've got -2 times a negative. So this is really, let me just, -b plus 1/3 times -2. So I'm left with negative, if I want to subtract that -1, we can do that in a minute. Maybe we'll just combine like terms in a minute. -1 equals 1/3. I'm going to distribute the -2 to both of these terms, so I'll get plus 2b minus 2/3. So I'll get -1 equals 1/3 minus 2/3 is -1/3 plus 2b, add a third. So -1 plus 1/3 would be -2/3 equals 2b. So b equals -1/3. Whew. And then, so your final answer is going to be, actually, I'm going to see how all of these factors have a 1/3 in them. I'm going to factor out a 1/3. So then a would be 1 over x minus 1 plus, and I'm just going to do negative x plus 1 over x squared plus x plus 1. And that would be your answer down there. So I'll do the last few examples on the next video.